So, Akshat, can you introduce yourself, please?
Hi, my name is Akshith. I'm currently going to grade 11, so I thought it would be good for me to prepare with Anil sir.
How
And
about, yeah,
yeah, that's pretty
how
much it.
about you, Jake? Can you introduce
Um,
yourself?
Hi, my name is Jake. I'm going into grade 11 as well, and I thought it would be a good idea to tutor with Anil Kumar.
Jaslyn, can you introduce yourself, please?
Hi, my name is Jasleen. I'm going to grade 11. I'm learning from Anil Kumar.
Yeah, thanks for joining in. And I hope during this summer holidays, we'll be well prepared for our September session, right?
Yeah,
So let me share with you the screen which I prepared specially for today's lesson. We'll talk about transformation of functions, right? We already know what functions are. We know function notation. We have also seen parent functions. And now in this lesson, we'll learn about transformation of functions. I hope you remember what you learned in grade 10 about transformations. In grade 10, you basically learned about all the techniques of transformations, but they were applied to parabolas, right? Here, we are going to extend it to all kinds of functions. And therefore, you will use extensive use of function notation in this particular video. So we'll talk about transformations, which is, you all can see my screen?
yes, sir.
Mhm.
Great. So when we talk about transformation, we are saying g of x is our transform function and f of x is the original function. In general, the transformations could be applied in the way shown here, where everything means something, right? So the formula for transformation given here is g of x is equals to a times f of, within brackets, k, x minus p, bracket close, plus q. Now, we'll take one by one all kinds of transformations. We'll begin with the vertical translations. So vertical part is actually governed by the outside parameters A and Q. So when we say translations, then Q is affecting the translations. For horizontal translation, the inside part P really affects the horizontal translations. Then we'll talk about vertical stretch, compression, and reflection, which is the value of A governing. The horizontal stretch, compression, and reflection will be controlled by the parameter K in this particular equation. Sketch, and then we'll take examples to sketch transformations, to describe transformations. Remember, transformations should always be described in a particular order, right? And then we'll have some graphs showing all the transformations. Here is kind of summary, and at the end of video, you will learn all these parts of transformation. So as I was saying, the value of A, you will learn that it could affect the function by vertical stretch by a factor of A, stretch when A is greater than 1. It will be a vertical compression when the absolute value of A is less than 1. That is, A is between 0 and 1. Okay. Reflection on the x-axis when A is negative. So if I have a minus here in the equation, that function will be reflected on the x-axis. Now, outside parameter q affects the vertical translation. If q is positive, then the graph will move up by q units, and if it is negative, the graph will move down by q units. The inside parameters, as I said earlier, affect horizontal. So K gives you horizontal stretch or compression. It stretches when the absolute value of K is less than 1 and compresses when absolute value of K is greater than 1. As far as P is concerned, when we use some function, we say phase shift also. It actually translates the function left or right. So if P value is greater than 0, the graph moves right. And if P is less than 0, it moves left.
Uh,
When the value of K is negative, then the graph gets horizontally reflected on the y-axis, right? So the reflection on the y-axis could be treated as a horizontal reflection. So that's a overview. I hope that is clear. Is that clear to you all?
yes, sir.
Yes.
So let's look into this one by one in details, how everything affects individually, right? So the very first thing which I'm talking about here is the vertical translation, means moving up and down. Remember, when the graph or the function is translated vertically up or down, the shape remains exactly same. Shape is not changing. The only thing changes is that it moves either vertically up or it goes down. That is it. That is vertical translation. Now, the parameter q, as I was saying, affects up and down movement. So if q is positive, right, if it is greater than 0, it is going to go up. But if q is less than 0, then it is going to go down. So we'll consider the equation
Yeah.
which is given to us as y equals to x squared plus 2. So in this case, can you tell me what kind of transformation is it taking place now?
Sir,
Yeah,
I think you would transform the parabola 2 units up, correct?
perfect, because it is plus 2. So the whole
Yeah,
parabola will move 2 units up. That is
yeah,
right. So every point will move 2 units up. You can just take some points and just move them 2 units up and then sketch your parabola. That is what it happens, correct? The x value remains exactly same. So if you have a coordinate point xy in general, then on this transformed function, the image point x value remains same, but the y value will be y plus 2. So you can make a set of values here, right? These are the key points. Remember, for every parent function to sketch, we have key points, correct? Always use 5 key points. That is a key. So for a parabola, these are good 5 key points to consider. So basically, you know the transformation, the x value is remaining same. So in this case, x value remaining same will remain as minus 2, but the y value instead of 4 will become 6. So at minus 2, the value which was at 4 will now move to 6. You can see it is a vertical translation of 2. Likewise, you will do for all the points. Select few, especially these 5, and sketch your parabola. It will look something like this. So what I did was I made a rough sketch as exactly you will do in your test paper, right? So rough sketches are good enough to explain all these concepts. So as you can see here, what I did was x values are exactly same, minus 2, minus 1, 0, 1, and 2. However, for each y value, I have added them by 2 and got 4 to 6, 1 to 3, 0 to 2, 1 to 3, and 4 to 6. Adding 2, getting my transform points, and then plotting them to move the parabola. Well, that is not necessary. As you know, from the graph also you could have pointed each point up by 2 and then connected them as shown here. So that is how you'll get the transform function y equals to x squared plus 2. Is that clear?
yes, sir.
Perfect. So we have seen how this parameter qx. Now let's look into the horizontal translation. Now can you tell me for horizontal translation, what should I be changing?
Sir, I think you should shift it 2 units to the left.
Okay, so you're saying about the function given to us, the parameter p needs to be changed for a horizontal translation. So we have taken a function y equals to square root of x plus 2. And since it is x plus 2, basically it was negative p. That means p value is negative 2, right? So in this
Yeah,
case, we have p as equals to negative 2. See, the function is different. This time the function is square root of x, correct? So
mhm,
we'll start with the basic parent function square root of x. We'll again take 5 key parameters. 5 key parameters are the 3 points shown to you, 0, 0, 1, 1, 4, 2, and the end behavior. You remember in a square root function, if x is approaching infinity, y also approaches infinity. Well, that's a very important thing to consider. So we are taking only these 4 things for the square root function. Now here, the transformation of the image points will be p-value is negative. That means the whole graph is going to move left, correct? So we are going to shift this left by 2 units. That is what is going to happen. So you can actually translate these points 2 units to the left, and then you will get your graph. Is that clear to you?
yeah,
Right? So you expect a graph which will be kind of like this. Well, take your time to fill up these values, and of course, what will happen? The X values this time will change, but the Y value will remain same, correct?
Yeah.
So the X values will become -2. I mean, you have to add -2. The Y value will remain same. Fill this up, sketch, and that is how you may see the values and the graph, correct? So the whole function, as we were talking about, has shifted 2 units left. That is what we are saying, right? So that is what happens. This is because of this. +2 means move it 2 units left. Horizontal translation, we have considered the effect of parameter P in this particular part of the video, correct? Now, let's look into another function. This time, we will do a translation. We are doing combination of translation here. The function is g of x equals to f of x minus p plus q. And we have taken reciprocal function this time, another parent function which you all studied, correct? So reciprocal function is shown here in green. You're supposed to actually sketch the transform function 1 over x plus 1 minus 2. So what kind of transformation is taking place? Can any one of you tell me? Yes, Akshay, tell me. What kind of
Sir,
transformation is taking place here?
I'm thinking that you should shift it down
Yes, by 2 units, that's
by
correct.
2 units, yes.
How about this portion? X plus
The
1.
x plus 1, then
Yeah.
that should be shifted to the left 1 unit.
1 unit left. That is absolutely correct, and that's what I did. So the image
Yeah.
points I'm going to get by changing the x value by x minus 1 and the y value by y minus 2. These are the key parameters, the key points for reciprocal function. Keep a note of all this, correct? These 5, 6 values. Now, each x and y you can change and get your values. Let's talk about horizontal and vertical asymptotes. That is very typical of any rational function, right? So, for the original function, we know that our vertical asymptote is right there, right? Now, vertical asymptote is being moved 1 unit to the left, so we expect it at -1. So that is going to be the new position for the vertical asymptote, correct?
Yeah.
As far as the horizontal asymptote is concerned, earlier it was the x-axis, but now it moves 2 units down. So the graph will accordingly shift. You get the idea, right? So now this x and y, think about the horizontal and vertical axis being shifted. So these are two very critical parameters to sketch any rational function. And therefore, I've taken them right on the top. So first you sketch the transformed horizontal asymptote and vertical asymptotes, and then the points to exactly get the curve, right? Here is the solution kind of, right? So it's messed up, but you can see very clearly that -2 is your horizontal asymptote, vertical asymptote at -1, since we shifted -1 unit left and 2 units down. Makes sense. Did the same calculation, got the other points. Plotting those points, we have the graph in pink from green, which represents your transform function. Are we clear about translations? We have already considered both kinds of translations together, horizontal and vertical. So is it clear to everyone?
Yes.
Yes, sir.
Very good. So now let's look into more examples, treat them. Okay, this one is a vertical transformation. So the function which we're talking about now is g of x is a times f of x. Now a results into what? What kind of transformation do you expect now?
A vertical transformation, sir?
That is correct. So vertical translation. Now in this particular case, I took minus value. Minus means reflection on the which axis?
X-axis?
X-axis. That is correct. So this is reflection on the x-axis. So we are expecting this graph to be kind of flipped, right? Kind of like
Yeah.
this. That is first part. And then 2 means a stretch factor by 2. So it will be narrower. It will be like pulled up, like strings have been pulled up, right? So it
Yeah.
become a narrower structure and reflected on the x-axis. And therefore, you will see that the points will change like what? X values are remaining same. since we are not doing anything as far as the translation of x goes, right? So the x values remain exactly same. However, the y values will become negative of the previous y value multiplied by 2. So negative 2y will be your y values. And plotting those y values will exactly get this cubic function. So in this particular part of the video, see, we are now considering the cubic function, right? So we have already seen the parent functions, parabola, cubic function, reciprocal function, and the square root function also. Great. So when you do all these transformations, in that case, what will you look? This will look like this, the graph in blue. So you've seen it has been vertically stretched and also reflected on the x-axis. These are your image points which are necessary to show, and they provide accuracy to your diagrams, correct? Do you understand the end behavior? Well, originally, you can see that the graph is going from negative infinity to positive infinity, right? That is, when x approaches negative infinity, y approaches negative infinity. Since we have flipped the function, when x approaches negative infinity, y approaches positive infinity, right? So that is the flip which we are talking about around the x-axis. Do you see that? And when x approaches positive infinity, y is now approaching negative infinity, as you can clearly see. So that confirms that overall it is perfectly fine. In between points, you have calculated and shows accuracy of the graph, right? Okay, now here is kind of a test question. We're just combining both the things. One, the vertical stretch factor, which we looked into. Second, the vertical translation, which we started with, correct? So can you tell me what is the effect of this particular transformation? We're talking about g of x equals to 2 times f of x plus 1. Anybody?
Sir, the graph would become a vertical stretch considering the a is greater than 1.
Perfect.
And the plus 1 at the back would mean that it will be translated 1 unit upward every point.
That is perfectly right. So that is what is going to happen. And now, Jesslyn, can you tell me what will be the image points change? From x, y, each image point will change how? Will x value change here?
I'm pretty sure it's the y value that changes.
Y value will change. How will the y value change? Y will become what?
It'll be multiplied by 2.
Yeah. Plus 1, because it is moving 1 unit. Correct. So on this graph, we are not given any key points. What you need to do is figure out the points, correct? So we can just read some points from the graph, mark those points at A, B, C, D. You get the idea now?
Yeah.
So let's say these are the points. We can say these are my points A, B, C, D, and E, correct? Write down these coordinate values and then fill up the transfer points and sketch it. That is how we are going to do it. So here is your solution. So what I did was I just marked few points as explained, got those coordinate points as f of x points, right? And as Jesslyn, you said, the transform function, the p-value, the image point, x values remain same. How the y values becomes multiplied by 2 and add by 1. And once you do that, you have a stretched graph of this particular function shown in red. Clear? Now, let's take horizontal, horizontal stretch and compression. So this time we're looking into the factor K, which is inside the bracket. This factor commands the horizontal stretch and compression and also reflection about the y-axis. So the function which we are going to work with is g of x equals to f of 2x. So we've just taken a general function here, which looks like a cubic function for us. Again, you need to do this transformation. Can Jake explain me what kind of transformation do I expect here? F of 2x. So this 2, which is the value of k, how is it going to change my graph?
Sure.
Okay, Akshit, can you tell me how will the value of 2 in f of 2x should change?
Sir, since k is greater than 1, it will be
Yeah,
a horizontal compression.
that's great. K is greater than 1. It is a compression by a factor of half, right? So it is a
Yeah.
compression by a factor of half, 1 over K. That's kind of tricky. Whenever you're working with the part of the function which is inside that square bracket, things go in the reverse direction. K value is greater than 1, mind it, but it is a compression by a factor of 1 over K, which is 1 over 2 in this case. So you expect the graph to be compressed, means it will move inwards. Do you see that? The
Yeah.
value 2 will come to 1. So this will basically move from 2 to 1. This will move from -2 to -1, right? So that is how it is going to change. And in this particular case, the points will be the p image points. The x value will get affected, not the y value, and each x value will get multiplied by half, right? So that is
Yeah.
how the transformation is going to take place. Is that clear to everyone now?
Yes, sir.
Perfect. So this is extremely important. We'll now take few examples with horizontal transformations. So here is the solution for the same. You can clearly see what is the effect of this 2x. So we brought this inside. Do you see from both the sides? Now the domain of the function, which was earlier -2 to 2, is -1 to 1. Half of it, right, from both the sides. Do you get the idea, right?
Yeah.
The y values remain same. As you can compare all these y values, they are all same. However, the x values are half of previous x values. And that is what we mean when we write a function g of x equals to f of 2x. So this is horizontal compression by a factor of half. Clear? Let's move on and take up the next part, which is kind of complicated. So we have a test type of a question. There are a lot of tricks involved in this. Two transformations are taking place, both horizontal. G of x is equals to f of half x minus 1. Now, Akshit, can you explain me the transformation for this particular function?
Yes, sir. So, given that the p-value is 1, it
Yeah,
should move to the 1 unit to the right every
yes,
point, and the k value is a half, and as you said, we should reverse it, right?
yeah.
So it would be 2. You would compress it by 2.
Horizontally stretch by 2.
Oh, stretched by
Use
2.
the word
Yeah, yeah.
stretch when you are multiplying by 2, okay? And use the
Okay.
word compress when you multiply by a fraction like half. Is that clear to you?
Yeah.
Clearly, our transformation points will change. Y value is not going to change. X is going to change. So 2 times x, since this is horizontal stretch by a factor of 2, and moving right means add 1. That is how the x value will change, y will remain same. As far as points are concerned, you have to read from the graph itself. So pick up the points from the graph. These 5 are good enough. Those turning points and important points have been taken. Fill the table up, right? And then sketch. I hope that is absolutely clear. So that is the complete transformation, horizontal transformation. We have considered horizontal stretch, we have considered horizontal compression, and also horizontal translations, left and right translations, right? So that brings us to important part of like combining everything. So we have done vertical stretches and compressions, vertical translations, horizontal stretches and compressions, horizontal translations. So now we have covered everything about this transformation. Here is another test question for you. The question here is, g of x is equals to f of half x minus 1 minus 1, as shown here in the equation. You need to write down the transformations and sketch the transformed function shown on this particular graph. Now, once again, Jaslyn, can you explain me the transformation of this particular function?
Um, the vertical translation would be 1 unit down, and
Yes,
the horizontal transformation would be, as you said, um, 1 unit to the like right,
right. Okay.
and then the horizontal transformation, it would be a stretch of 2.
That part is correct. However, there is a catch in this. So what we have to always consider is, you remember, you look at this again. K is factored, right?
Yeah.
K is not combined with x minus p. So Akshit, can you correct me on this? How should I be
Yeah.
reading the transfer? Yeah, tell me.
I think it would be half, and then you factor out the half, is what I mean to say, and then x minus 2.
Perfect. So
Yeah.
that is very important. So if you don't do that, then you actually make a mistake of right translation. So it is not 1 unit right, it is right by 2 units. So you have to factor this k value out. Is that clear, Jesslyn?
Yes, sir.
Absolutely important. So never make this mistake in the test paper. 50% students will always make this error of getting a wrong value for the right horizontal or left horizontal shift, since they had not factored the k out. Well, now we've done it, we know it. That is a good place to make a mistake while learning, right? So here is our solution to the same thing. So the very first thing which should be done is factor half out. Once you do this factoring, then you proceed forward and you write the points. Now, you know, horizontally, the x value will be multiplied by 2 and added by 2, not 1. And then as far as y is concerned, just take away 1 and sketch your graph, right? Read the key values from the graph itself and then plot it. So you find it interesting and useful so far?
Yes, sir.
No difficulties, right?
No difficulties for me so far.
Perfect. So let's move on and take up another test question. Jaslyn, I would like you to answer this question. Can you please read the function which we are interested in?
G of x equals to 1 half of f. 1 over 2x plus 1 minus 1.
Correct. How will you write the transformation? What is your first step, please?
You would well, there is a vertical translation.
Yeah,
of
okay, there's vertical
-1.
translation,
Yeah,
okay.
but then like for the last question, I think you have to like factor out.
Yes. Yeah. So let me again summarize this part. There are a couple of things which are very important in adding all the transformations together, and that is, whenever you do transformations, that should be described in correct order. Like you have bed mass, right? So you have to open the bracket, multiply, divide, all those things, then add and subtract. Similar format is being maintained for transformation always. So my suggestion in order of operation is always move from left to right. Okay, so when you hit this first, this is your vertical stretch or compression. So because it is half, you will say vertically compressed by a factor of half. And when you move inside, you need to factor first. So first step will be, in this particular case, we need to factor, right? So this is a very important note here, factor K, and then describe your transformations. So as soon as I factor, I get a function which will be, let me rewrite here, half of f, and then we have half here factored out, and we have x plus 2, right? And then we have minus 1. Now, when you want to describe, so you'll describe in this fashion. First is this, which is vertical stretch by a factor of 2. That is the first thing. Let me write in short the correct thing also. Vertical stretch by a factor of 2, and vertical compression by a factor of half, and here we have a horizontal stretch by a factor of 2. Then we have a horizontal translation, 2 units left this time, and this is your vertical translation, 1 unit down, correct? So that is how you're going to describe your transformation, and that is how you're going to implement it. Perfect. That is how you're going to implement it. Now, clearly, you have these points marked on the graph. Read these points, make a table of values. Also write down, if your original point is pxy, what is going to be your image point? Clearly speaking, look at the x values. You're multiplying by 2 first, and then you're moving left. That means take away 2. As far as the y values are concerned, they become half of their original value, and take away, multiply by y, and then take away 1. And that is your transformed image points. So you can plot these transformed image points and then sketch your function. Is that clear to you?
Yes, sir.
Sure.
Perfect. So here is the solution for the same as I've written here in this particular case. So first part is to rewrite the function with factored k value. Once you do that, then as far as the order, the correct order is always from left to right. So left to right means start from here, okay? And then move right. That is what we mean, left to right. So vertically compressed by a factor of half, horizontally stretched by a factor of 2, right? So that is how it should be. Horizontally stretched by a factor of 2, and then translate. So when you write translate, you can combine both the things. You can translate 2 units left and 1 down. You can combine them, okay? So that is how you're going to get. Remember, this is the order. Stretches and compressions will come before anything else, right? Stretches, compressions, reflection is kind of multiplication. You can mix and match these, but after that, you have to write translations, right? Then you write translation. Is that clear?
Yes, sir.
Clear. So that brings us to almost end of this particular lesson. I think we have one more question here as a test question. So at this stage, well, okay, this is the same question. Probably I've sketched it later. So these are the points. I'm just showing you the answers, but you should be doing it on your own now. So these are the transform points which you can see. Make a table like this and then sketch your function, right? So that is how you'll do it. Here is your test question. You can actually take a picture of this particular page. I'll also share with you this particular video. Then you can pause at this stage and make a transform function sketch, right? So what you need to do here is you have to describe the transformation in the correct order to sketch the graph of this particular function. Akshit, can you summarize how will you answer this particular question?
So, sir, given that there is negative on the factor of a, the graph would reflect over the x-axis,
Correct.
and there's a half, so it would be a horizontal stretch of 2,
Correct.
and your graph would be translated 1 unit to the right and 1
Correct.
unit down.
Perfect. And the order was absolutely correct as you move from left to right.
Left to
Correct.
right. Yeah.
You make your table of values. Correct. You make a table of
Correct.
values and you have these points. Take 5 points to define this particular function and sketch the result. So that could be the last question, your test exercise. Did you all understand all this?
Yes, sir. I'm comfortable with it.
Okay, so that was good. Akshat, can you summarize for me what did you learn in today's video?
So in today's video, sir, I learned in depth about the transformations of functions and basically how like each movement of the function affects like each part of the graph. For example, like vertical stretch, vertical compression, horizontal stretch, horizontal compression. And like if it's like a negative in front of the A, then you reflect the graph over the x-axis. So there's different components to transforming and translating functions.
Perfect.
Yeah.
Jaslyn, what did you learn about today's lecture, from today's lecture?
Well, I've learned about the transformation of functions and each of the individual components that make up the function rules, like the vertical translations, horizontal translation, transformations of vertical stretches and compressions. Yeah.
So you are comfortable doing any question now on transformations, correct?
Yes.
No
Yes, sir.
doubts.
Nope.
Jake, What did you learn, and how comfortable are you now with this transformation of functions?
I'm somewhat comfortable with it,
Mm-hmm.
and I learned more in depth about the translations and transformations in
Okay.
different functions
Mm-hmm.
this lesson.
Perfect. So last question we have for you as an exercise. I'd like you to answer that question as an assignment in details, submit it to me. And next lesson, before we take, I like to go through your solutions, and then we'll move forward with this curriculum on MCR3U functions. Okay?
Yes, sir.
Thanks a lot for joining. It was a great pleasure, and I hope you learned. Thank you.
Thank you, sir.
Thanks. Bye. Bye for now.
Bye.
Right.